Everybody, and welcome to the first session of the day. It's going to be on analysis from the cloud. We're going to have two papers in this session. First one is titled Veil in the Cloud, Assessing the Prevalence of Cloud Computing in the Email Landscape. It will be presented by Martin Ense. Martin is a final year PhD student at RWTH Aachen University and working as a researcher and head of security and privacy at Cloud Surveillance Group. His research focuses on security and privacy in large-scale communication systems.
Thank you very much for the introduction. So this is a joint work with Mary and Oliver, who are both here today. So that's my first conference presentation where all authors are there, so I'm really excited. So what motivated our work is that we saw it's the rise of cloud computing. This is just some number for Gartner. You can take any numbers, and the important observation is that there is an increasing use of cloud resources. And specifically for this paper, we did ask is that what is the impact on the email landscape? I mean, there are a lot of impacts in the growth of cloud computing, and we specifically focus on the email landscape. And so we set out, say, what does the email landscape traditionally look like? And very traditional in the very original setting, when you send an email, you just connect to your own mail server or the mail server that you as a sender use, and your mail server forwards the mail to the mail server of the receiver, from where it goes eventually to the receiver. And then we set out and said, okay, but how does that change when the cloud comes into play? So first of all, of course, we have what we had before the cloud is traditional email providers. Email providers are defined as something where you get an email address that is something at providerdomain.com. In contrast, we have email hosters. Essentially, they provide the same service, but you use your own domain. Or they allow you to use your own domain. But still, the mail server is operated by some third party. So we observe that nowadays, depending on how you define cloud, but as we define cloud, these are all run in the cloud, at least the bigger ones. What we also noticed is that email is operated on cloud infrastructure. That is, people are renting virtual machines from Amazon or Microsoft and running a mail server there. Also, there's some email security offers, for example, spam protection or DDoS protection. So you would actually configure your host name in the DNS system to use that mail server. That mail server is kind of a firewall for all incoming emails, and then will then forward all emails that are benign to your actual mail server. And then we also have an increase in email marketing. That's these fancy newsletters that you get. They are nowadays also nearly all operated in the cloud. So why is it important to study this impact of cloud computing on email users? So the first thing is the question of infrastructure robustness. So we see a change, and the question is what is the impact of that change? I mean, you can likely argue that when mail servers are operated more professional by people that operate a large infrastructure, availability might increase. On the other hand, if you have an outage, for example, of a complete Amazon data center, then probably that will impact more users. Of course, you have security concerns, as we've seen, for example, with Yahoo. So if you're concentrating emails at a very few providers, then you only need to break into one of them and get a large fraction of emails. And of course, you have this whole privacy and jurisdiction discussion. So email providers in the cloud typically operate for free, or at least they don't ask you directly to pay with money. So what they will do is that they will exploit either the content or the metadata of your email, for example, to show you targeted advertising. And of course, you lose control of who has access to email if it's run somewhere in the cloud, and perhaps you don't even know about that. And of course, especially certain governments will be interested in accessing these emails. Luckily, not in Germany, because as far as I understood yesterday, one court ruled that it's not allowed to have these storage of who's communicating with whom. So we are lucky, but the others are not. So we are studying two questions in this talk. So the first is how prevalent is the usage of cloud email, and the other one is this usage visible to users? So can you, as a not totally expert user, figure out that your email has been routed over a cloud or not? So as a foundation for that, we somehow decided, or we somehow need a set of providers that we want to study. And so what we actually did is we took the categories I showed you before, and we try to figure out like what is the most important one for each category. So it's essentially like a combination of a literature study and reading a lot of white papers and looking at statistics and stuff like that to figure out like which are the huge ones, and then like in the second step we used a random subset of our data and verified that we didn't miss anyone. And so it's not very important to look at the table, it might be a bit small, but just so what you need to keep in mind is that for each of these, we cover the most important providers, and there's no provider missing, at least for the random subset that we sampled. And then we set out and said, okay, like the first question that naturally pops out, how prevalent are these providers in the global email infrastructure? So we set out and did some active measurements. So essentially we just used the port scan that has been in on it. Port 25 TCP on the whole IPv4 address space, and essentially just making sure that there's really an SMTP server running. And we tested essentially the IPs of these mail servers against the IPs of the cloud infrastructure providers that we were interested in. This is not all providers, just the 10 cloud infrastructure providers. And what you observe here is that about 1% of all global mail servers, all globally reachable mail servers in the internet are run on Amazon infrastructure. And yeah, I mean the other ones are not that important. But in total you have about 1.4, 1.5% of all mail servers that are publicly reachable on the 10 largest cloud infrastructure services. So this is like a first number, and it seems that there seems to be a trend of having email on cloud infrastructure. But I mean, just because there's something listening on port 25 doesn't really tell you if that's like a mail server that's in use. So we had a look at the other end and said, okay, let's just look at what's actually configured in the DNS system. So we were lucky that we could get the zone files for comnet and org. And what we actually did, we just looked like what is configured as mail service for these roughly 150 million domains. And then we tested them against host names and IP addresses that we knew for the providers. And yeah, I mean, first result is quite surprising on the first take, because like nearly 1/3 of domains that have an MX configured use GoDaddy as mail server. But if you think about it, that makes sense, because GoDaddy is like the largest web hoster in the US, and a lot of people that just register domains in order to sell them later on, they use GoDaddy and they just use the default configuration. Nevertheless, roughly half of the configured MX use a mail server in the cloud. Like all the different categories of cloud providers, we didn't see like, at least like for the reasonable numbers, any marketing services. So they are really just using like 1 or 2 domains to send out their advertisement or spam or however you want to call it. So what we can observe from this first measurement is essentially that when we scan the IPs, we get a different picture than when we look at the DNS. But nevertheless, we can tell that cloud computing is definitely used to provide email infrastructure. And these results are kind of a good baseline if you're interested in when I'm sending an email to someone, will it end up in the cloud? Because you can essentially figure out, like based on the host name, which MX is configured. But what it doesn't really tell us when we just measure the infrastructure is how it's actually when we're receiving emails. Because, I mean, just like having some infrastructure configured doesn't really tell you if there's a lot of emails flowing over that or even emails at all. So the main part of our paper essentially is about how is the prevalence of cloud computing when receiving emails, like actually receiving emails. And if we're looking at received emails, we have some information available that we want to exploit. So for those of you that are familiar with how SMTP works, it's just like more or less human readable header. So like one of the first emails I actually used to send, I just typed it in using Telnet, so back by the time that it still was possible without getting flagged as spam. So it's just like each line essentially defines some keys, and then you have a value, and the information in there we can use in order to detect over which infrastructure that runs. So first we have those received lines, and the standard for email essentially says that like whenever a mail server touches an email, so it's like one of the hops that's used to deliver email. Of course, we are talking about application layer hops, no, not layer 3 hops. They need to add such a line. And what you see here is essentially, so this is the example where I guess Mary sent me an email, so this is coming from her Google account to my university account. You see the host name of Google, and you also see an IP address that is owned by Google. What you also see is there are some fields that are not really mandatory, so we call them custom header fields. You have this DKIM signature and the Google way of doing that, the same thing, which essentially is used for spam protection. So this is actually a signature over the header, and you could verify that this email really comes from a Google server, and if not coming from a Google server, you can just drop it. And I'm not 100% sure what this is about. It seems to be some encoding of the Gmail message state. This is just some base 64 encoded value, but just by the presence of this field, you can tell that this email has been run over Google infrastructure. We also have other information, for example, where it is coming from and the message ID. And the message ID essentially also is bound to the mail server that the email originates from. This information can be faked. So in our work, we only use that to figure out if an email or if the usage of cloud infrastructure is visible to the user. So here, I mean, if you see that an email is coming from a gmail.com address, probably you wouldn't be surprised if I tell you it has been going over cloud infrastructure. But if it would be something else, then you probably couldn't tell, at least without looking at the headers manually. So the interesting here is that in contrast to just measuring infrastructure, we see the whole received path. So we see all mail servers that have been hit on the path. Okay, so what we did is we assembled some data sets. So in total we have more than 30 million emails. Mainly these are mailing lists and a spam trap. For those information that are publicly available, so we can't directly provide them to you bundled, but we provide you with scripts that you just need to run and download it yourself for legal reasons. It's all on GitHub. If you want to play with that, just use the script and you will get a copy of the data set that we used. Okay, so the first thing that we were interested in is we just said, okay, yeah, let's look at the data. We have roughly 2 decades of data, so for each of the data sets represented by different colors, how is the usage of cloud infrastructure increase or decrease, so what's the trends there? You see, like, the smaller the data set, the more sketchy are the results. The mailing list data set is the largest one, and you see that it's a smooth curve. And you see that there's like a really huge increase in cloud usage until 2011, 2014, depending on the data set. But then there's a drop, so it's really funny, and we are not sure why that happened. So perhaps it might be all this Snowden thing or whatever. But really in this part of the data set, of course, it's a bit biased because like the mailing lists are mostly technical mailing lists like IETF, Apache, and so on. So probably people really decided to move away from cloud infrastructure. But still, like at the end of last year, it was, depending on the data set, between 16 and 25 of all emails have been processed by a cloud service. And here, our definition is one cloud service. So a lot of emails actually get processed by more than one cloud service. So then we set out and had a deeper look and thought, yeah, who's causing that? So for each of the data sets, we plot the 5 top cloud services by usage. And what you essentially see is that Google, not very surprising, is processing about 10% of the emails for all data sets besides the spam data set. So the spam data set, you see there's essentially nearly no cloud usage. And what you also see is that for the users data sets, which is 20 volunteers that agreed to run our scripts and code on the data, that there are more services. It's partly biased. You see that 1&1 is quite prevalent there because that's like one of the largest German email providers that you can use for free. But but also like you see a lot of Amazon. Probably we can't look into the details because we only get the aggregate from the users. That's for marketing emails that you of course get as a user but not on mailing list. But the important message here is that if you're receiving email, and even if you're not using a cloud service for your email account, still about like 10% of the emails that you receive are at some single cloud service. In this case, it's Google. So now the question is, maybe if it's visible, that's one thing, but do users really know about that? So what we set out is to study what we call hidden cloud exposure. And what we define as hidden cloud exposure is that an email is handled by a service that is neither visible from any address that is in the sender file nor in the receiver field. So it's just some Google address, either from sender or receiver, and it's handled by Google. We'd say, though, that's not surprising, that's not hidden. The user can figure out. If it's not, that's hidden. And what we essentially see here is that for 2016, roughly 4 to 8% hidden cloud usage is just for the total email. So it's not like 4 or 80% of all cloud usage, but it's 4 or 80% of the global email usage. The trend is quite similar to the general usage trend. And what that means is, depending on the data set you look at, it's 30 to 70% of the cloud usage that actually happens cannot be detected by non-experts. So, I mean, I'm able to detect it if I'm interested, but I can't tell my parents to look at the header and then figure out that some obscure host name is used by cloud infrastructure. So then we said, okay, again, just look at the providers that are calling that. Again, we see which are the providers that are calling that. And essentially what you observe is it is hosted, and that's kind of what you expect, because if I'm using my own domain name, just by looking at my email address, there's no way to figure out where it is hosted. It's email infrastructure running on cloud infrastructure, so virtual machines in the cloud, and these what we call hybrid services, like Google, for example. I mean, Google is an email provider. You can also use Gmail with your own host name, and Google also offers you to buy cloud infrastructure. And it's really hard to tell by looking at IP addresses for Google, like which part of their business units it's coming from. So what you also see is for the spam data set, essentially all cloud usage is hidden. So there is very few cloud usage, because that makes sense. Because, I mean, as an operator of cloud infrastructure, you don't want anyone to send spam over your infrastructure, because that's a bad thing, because you might get blacklisted and so on, or you have to handle all the abuse messages. So they are dealing fairly good with preventing spam being sent, but if it happens, then typically people try to put some email address that hides that is coming from the cloud. And this makes sense, because, I mean, for spam, you want to have like a good visibility. Okay, so a bit of discussion about limitations of our approach. So especially like the more detailed analysis in the end, it's inherently limited to incoming emails, because only the header information contains the full path, and you only have the full path as the receiver. So we can't really observe the full path for outgoing emails. So if you would like to look at outgoing emails, you can look at the first hop, or you need support from the receiver. So the detection patterns that like IP addresses, host names, and so on, or custom header fields that we use to detect cloud providers, they of course can change over time. And it might be that our patterns might not be accurate for the past. But what we were interested in, is that really the case? So what we essentially saw is that host names and custom header fields, they more or less stay constant. Of course, we have new providers arising, or some go out of business, but it's not that Gmail suddenly decides we're using complete new host names for infrastructure. And for the IP addresses, for cloud service, you essentially see that they grow, but nobody would abandon IP addresses. So for the very old data that we have in our data set, we did some random sampling to make sure that we are not causing error problems, and it seemed that our information really isn't wrong. So we didn't see any false positives there. And of course, like the biggest limitation that we have is, I mean, there's a lot of manual effort into selecting a representative set of cloud services that you want to study. You can, of course, further enlarge the set. I don't think that's very beneficial because you won't cover much new providers just based on the numbers that we already cover. And this is a lot of manual effort. To make sure that we didn't miss any providers, I already told you, we also did some random sampling and checked that we are not missing any huge providers. Okay, so because before I want to wrap up, I just want to literally peek into the future what we're currently working on. Currently, we're applying this methodology to build awareness tools for the cloud usage of smartphone apps. So you see some screenshots where you essentially see, like, for this app, which is just a famous German news site, which cloud services are actually used, where the data center is located, and so on. Okay, so some key observations and a conclusion. So if you look at received emails, you see a different story than when you just have make active measurements of infrastructure. So the infrastructure study is good if you want to see how is adoption of cloud email services on an infrastructure level. But when you want to look like what's really the impact on users, you need to look at received emails. Email users definitely are exposed to the cloud. 13 to 25% of all emails received in 2016 in our data sets were exposed to the cloud, and single cloud services and also like the law enforcement bodies that have control over these cloud providers have access to up to 10% of emails. And this usage remains undetected. So 13 to 70% of all cloud usage is hidden from non-experts. Okay, thank you very much for your attention, and I'm happy to take any questions.
Questions?
Could be the decline of the email cloud usage due to the Snowden leaks and the rising awareness, data privacy, and about mass surveillance?
It could. I mean, it's pure speculation, so we have no data to back that up. But as like most of the mailings that we have are technical, I would assume it is, but it's hard to tell.
Nice work. Can you imagine some automatic way to do this? Because it seems to be a lot of manual inspection, a lot of manual rule derivation, and so on and so forth. Will it be possible to think about some machine learning to try to automatically digest the errors and figure out what are the important ones, and then looking for the most prominent providers and things like that?
I don't know if you even need machine learning for that. I mean, it's just looking like which are like prevalent IP addresses, somehow clustering them. So there was a CCS paper by, I guess, Steve Engelhardt last year, where they did this for websites. And what they essentially did is they clustered host names based on some email address that was listed in the WHOIS data. So they said, like, I don't know, like the technical contact, like it's a technical contact for two domains is the same, then probably they belong to the same organization. And of course, you can do something like that. So the problem here is that we also wanted to be tested out by users. So we somehow needed a pre-configured set that we could hand out to users because we didn't want to ask users to give us their email. They just got a little Python script that they could run on their computer, and we didn't see the emails. But of course, like if you would now say, okay, based on the results, it's worth to further study that, or you want to turn it into like a product or an open source tool that users could, for example, install in their email program, then of course you could do something like that.
Okay, thank you.
When you talk about the exposed users here, does that, I didn't understand if that included emails exposed emails. Does that include if you say look at the CC line and you try and determine was anybody else on this email CC'd on the cloud provider?
So for these numbers,
Yep.
this is like what we observe, and we don't really care about like who is it going to or where it's coming from.
It's based on
It's
who it's
based
been
on
through.
exactly, and
Yeah.
here,
Mhm.
even if it was on a CC line,
Yep.
we said okay, like if like you are with your Gmail address in the CC line and I received the email,
Yep.
also I'm aware of that it ended up at
Okay.
Google if it did end up on Google.
Right. Okay.
But because we don't really know if the email ended up at Google, just because there was someone at the CC, we didn't count it for the overall numbers.
Okay.
So we always took like the more safer number, so just to be sure that we don't make any errors, or that we at least minimize errors.
I'm also wondering, in your graph for the mailing lists, you show some cloud providers kind of between 95 and 2000. Is that the start of Gmail, or who is that? It sort of rises a bit before.
So
2000.
this is probably Hotmail, so I'm not 100% sure.
Yep.
And also, like, I don't know what's there was some Apple Mail before, which is not like the same as iCloud today.
Yep.
So this at mac.com and
Something
so
like
on.
this.
Yeah, so these are like the first services. So probably back then you wouldn't have called it cloud, but still it was what we would classify as cloud today. Like
Okay.
large infrastructure, highly distributed, and so on.
Initially, when you were doing an IP-based scanning of mail servers, how did you make the distinction between an IP address that is within NTT and it's being hosted on the cloud side, or whether it's just a regular server being run by somebody?
Okay, so what we actually did is like we have this list of 10 cloud infrastructure providers that we were interested in, and either if this is like a nice cloud provider like Amazon or Microsoft, they provide you with their IP addresses, and if not, we just use the whole AS of that provider. And luckily, like those really big providers, and also where like the AS structure is not so clustered, we got the information directly from the providers. Only like the very smaller providers, we just have like one AS for the whole provider, and it's essentially only used for delivering the service. We just use all IP addresses in that AS.
Thank you.
I have a curiosity. I see that from the dataset of the spam, there's no Google there in the box,
Yeah.
the red box. That means that Google implements the best anti-spammer system.
We can't tell.
Uh,
So there is some Google, probably it's faked. I mean, that's also like a problem you have. Not so much for regular emails, but for spam definitely. They try to somehow fake that it's coming from Google. So I would assume that it's not really possible to send out spam at a large scale over Google infrastructure. Because I mean, for Google that would be a nightmare if their reputation goes down and you can't send emails anymore. So like the bigger the infrastructure, so the more work they put into making sure that they are not abused and then get blacklisted.
okay, so there is no more question. Let's thank again Martin.